Hello friends, welcome to Unacademy, which is the largest online education platform for GATE, CS and IT. Myself Mallesham, I'm taking here theory of computation. This is the second session in TOC, which is a finite automata. In the first session, we have understood a little bit about regular expression and regular grammars. And now it's the time to understand about the finite automata, which is another model and another representation of a regular language. So what finite automata does, that we are going to look at. It accepts regular language, it recognizes regular language. And how do we design a machine? So automata is a machine where it's going to recognize the set of strings. Whenever you give a string, whether it is valid or not, it's going to help us with the representation of the finite automata. Yes. And finite automata is a theory, so don't assume it will tell you. You have to design and you have to understand the way you have designed. Yes, it has the particular approach to design. Then we will learn today how to design the finite automata, as well as we will understand what kind of languages it can accept. Yes. Good morning, Vijayant. Good morning, Nishu. Good morning, Gaurav. Good morning, Nikhil. Yes, good morning. Good morning, Chaudhary. Good morning. Okay, if you are not aware of the schedule of the TOC, we have completed first 9th Jan, and today is the 10th Jan, so which is finite automata. Then tomorrow we will have closure properties and identifying regulars, and so on. So have a proper plan to learn as per the given schedule. Yes, Sandeep, good morning. Amjad, good morning. Yeah, Saurav, good morning. Right, after this we have maths at 11:30 a.m. after my class. So my class is C languages completed. Now it's a TOC, and after maths you have COA at 2:30. So my class it's a TOC right now, which is started, and from tomorrow I think algorithm is going to begin by Ankush sir, and soon operating system data structure will begin by Khalil sir and Ashdeep sir respectively, and all the subjects will be covered soon. The tentatively planning is 29th Jan. Okay, if you are not aware of my classes on Unacademy, just I take the classes for TOC, CDC, programming, discrete maths, and other favorite subjects are also there, algorithm and data structure. So first 4 subjects you can find a lot of classes. And in case you need my referral code, use DEVALIVE referral code to get 10% discount. Also, which will help you to access the free classes on Unacademy, guys. Yes, good morning, Lovjit. Late. Simon, good morning. Saurav, good morning. Aditi, good morning. Yeah. And these are my, classes that you can find if you visit our academy. Quizzes, all-in-one sessions, and special topics on many subjects, daily practice problems, and PYQ series on many subjects. You can see more than 400 classes are available, which is nearly 450 hours content available on Unacademy. In case you are not aware of the Unacademy learning app that you can use on mobile, so go to Play Store and install Unacademy learning app. You can use right away. And we have 2 popular plans, Plus and Iconic. So you might be asking, I'm getting the messages from many people on groups. I can see them. So Plus is you have live classes. It's not like other courses on other websites. You can see that if you join anywhere a particular batch, you are not eligible for other batch. But Unacademy is not like that. If it is just duration, if you take 1 year, if there are 100 batches are going to be running in this 1 year, you can enroll for any batch or every batch. It is your choice. So it's unlimited access to any course from any educator. So Plus have a lot of benefits compared to any other platform that you are looking for GATE syllabus. And live classes, that is the most important factor. Other people might have a limitation on how many times you watch the video, but here you don't have limitation. Only limitation is the plans that you take 2 years or 1 year, that's your choice. But once you come inside, you might be using my referral code, but it doesn't matter. Even you can use this referral code for any stream, right? Mechanical, civil, electrical, electronics, it doesn't matter. This code is just helps us to get a popularity, and you will get a discount. That's all. But if you don't want a referral code, you can directly enroll to the courses, which is absolutely going to be well structured, and you will have many batches like crash courses, rank improvement batches, doubt solving for every course on every 4th day, and you will have English, Hindi, and you will have weekly test. So a lot of benefits on Plus. Iconic already you have the Plus, but what are the benefits through the Iconic is, in case you are not aware of how to prepare, you will be assigned with a coach, so that he or she is going to help you all the time to prepare for the exam. That is what the Iconic is. And you will have a study plan separately designed by expert, and you have booster sessions and test analysis, separate material, and all the things are going to benefit you a lot. Okay, in case if you want to see the plans, like Plus I am talking about first, where 2 years you can see the price 39,600 if you use the DEVALIVE referral code. Similarly, you can see other plans also. And if you look at Iconic, which is far better than Plus, and you will have at 66,600 for 2 years. Yeah. So if you are watching this video, please like the session so that you can see how many are attending now. Yeah. Dohi, good morning. Umesh, good morning. Yeah. If I miss anyone, guys, good morning. Fine. Are you ready, guys? How many of you are seriously preparing for GATE 2021, guys? Yeah. Not everybody serious, because I can see in the beginning 80, 90 live. Then if we are going further, then people are getting off. The reason is the dedication. Yeah, good morning, Chakraborty. Ready? Fine. Lovjit, okay. Who else? Nishu, Abhishek, Sandeep, Ritika, yeah, Sachin. Okay. Good morning, Sandeep. Pratiksha. Yeah. Please respond. Please respond. Yes. Good morning, Aparna. Ready? Good morning, Vaishnavi. We have seen these 3 topics: introduction, little bit about Chomsky hierarchy, but there is a lot to learn in coming chapters. Regular expressions, regular grammars have been completed. Now we are going to look at finite automata, DFA and NFA. These 3 topics we are going to learn in this session. Good morning, Ram. Okay, so what is finite automata? How many of you know what is finite automata? You know, finite automata. In this automata word is a Greek word which is used for machine, to represent the machine in English. Yes. Now I am talking about one machine, so finite automaton I am talking. So what is finite automaton? Yes. What it does? Can anybody see that? Yes, we can design. You give a string, let's say W. This is over particular sigma we are talking about. So I am assuming this finite automata accepting some language. What it has to do, if W string belongs to L, it should say as it should accept, or we should understand whether it accepts or not. If W not in L, then it should not accept, means it should reject. Yes. Yeah. Yes. A finite automata. So whatever the language it accepts, we can call it as a regular language. Exactly. So finite automata accepts always a regular language. You can call recognizes, or you can call represents. So if anybody asks what is the language accepted by finite automata, what do you say? Regular. But which regular? That depends on the particular machine. Yes. So everybody clear about what is the finite automata? It is a machine that accepts or recognizes or represents a regular language. It can't generate a regular language. Remember, we don't do such machines now, right? So now what is finite automata? It accepts a language. That language is called as regular, and it is going to represent a valid string and invalid string somehow. We are going to understand. Yeah. So this is a configuration. In the configuration we have tape. We call input tape because there is no, we are not sending any output. We are not doing any output on this machine. This is like a pointer head. It's just going to read from the tape, and this on this tape we are going to read the data only from left to right. Yeah. Now let me give you something here. This is my input, and what is this box represent? Finite control, your machine. Your whole logic is here, and what it does, it's going to read a symbol by symbol, one symbol at a time, guys. One symbol at a time. It's going to read one symbol at a time. So what it does, once a string is over, it's going to move one symbol at a time, but it does some actions and finally it halts. When it halts, we are going to look at where it halts. So to represent all this entire machine, we need 5 parameters. What are they? Q, sigma, delta, Q naught and F. What is Q here? What is Q? Set of states. That Q might be here, the set of states that you can see in the finite control. And what is sigma? Is the input alphabet, like sigma here is A comma B. All input symbols are there in input alphabet. And delta is your transition function that depends on the machine type. The transition function is going to change. For DFA and NFA, that we will see later. And Q naught is a start state or initial state. And F is set of final states. If you look at here, the Q naught is belongs to Q, but if you look at F, F is subset of Q. Yes. So you should be aware of every parameter when you are talking about finite automata. You don't understand even single parameter, there is no use of finite automata. Yes. Then what is the transition function? Right now it's really going to be difficult because without looking at a machine, it's very difficult to understand what is the transition function. Yes. So let me help you. Transition function, before the transition function, guys, I will help you representation so that you will understand, because in this, if anything is important, that is delta. Those people who can understand this delta, they can understand whole machine. Yeah. So let me help you representations. Okay. Don't worry, is it DFA or NFA? I just take care of something. Okay, some machine it is. Okay, there are two states. There are two states here. Fine. Now, this is called a state diagram. What is this representation? State diagram. Okay, in this state diagram, can you help me? What are the representations are there? What are the parameters to talk about? Here, you should know about what is P and Q. Here both are states. And what is sigma? That is A comma B are the input symbols. And what is delta? That is whole motion represents delta. And who is the Q naught? Q naught is a P. And who are the final states? Only Q is the final. Yes. Yes, every topic will be covered. क्या syllabus list करने के बाद भी doubt आ रहा है तो fine. Transition table. Next one. And look at in the diagram, initial state we always represent using arrow and circle. And how do you represent final states? With double circles. How do you represent non-final? Single circle. Yes, everybody? Clear? We have set of states. Some are final, some are non-final. Single circle is a non-final and double circle is the final. Initial state is represented with specially an arrow followed by a circle. Yes. Now, next one, transition table. How many rows will be there? 2 rows, P and Q. Who is the initial state? P. Who is the final state? Q. You can represent star Q, means final state. Or you can represent circle Q. And now look at from P. I can help you. From P by reading A. Are you going to P? Yes. From P by reading B. Are you going to Q? Yes. Q on A. We are going to P. Q on B. Self loop. That is a Q. And this is the delta table, transition table. Here every parameter in the machine is represented inside this table. Yes. And we have another one. You can use functions, this mathematical model. Of course, all are mathematical model. But now I can represent using some other way, like finite automata is equal. Q means like a P comma Q. Sigma is A comma B. Delta is defined below. And Q naught is a P and final states are Q. And where delta is defined like that, 1, delta of P comma A is equal to P. Second, delta of P comma B is equal to Q. These are the mappings. And it is your choice how do you want to represent. Is it clear? You can use state diagram, you can use transition table, you can use functions or set representation. Yeah. So all the three are equivalent representations, guys. In the exam, they could ask anything. Even this 4 I can represent some other way too. I can write one set. Delta is equal to like P comma A that maps to P. Even every transition I can write as a one pair. Like P comma B, I will move to Q. And another pair where Q comma A goes to P. Did you see that? This is another way to represent. Yes. You can represent as a set also. Delta is actually a transition function but also is a set. Yes. Many ways to represent a same machine. In the exam, if you look at the set notation, you might confuse a lot because you don't know that notation. So look at the diagram, table and set function notation is also possible to represent a finite automata. Yes. Okay, these are the representations of finite automata. And now I told you DFA and NFA. DFA delta and NFA delta. Here Q cross sigma maps to Q. Here Q cross sigma, possibly epsilon if you want, you can take 2 power Q. And what is the meaning of that? What is the meaning of that? Here, from each state, for every input symbol, that's about domain. For every input symbol, there is exactly one transition to the next state. Here from each state, here for every input or no input, anything is happens here, because epsilon also possible. For every input or no input also happens. Anything happens, any number of transitions, but definitely finite. Any number of transitions possible. Yes. Everybody, look at how difficult to understand transition function. It is a definition of a machine, guys. If you know the delta definition, that means you know the definition of a DFA. Everybody? Yes. To understand this, people take, I took years to understand the definition of delta, guys. You don't, you may surprise, I'm very much weak in mathematics before joining ISE Bangalore, where I went for PhD, and there my guide used to explain all these things, but really today I'm able to understand mathematics because of I did some kind of research little bit on every terminology that we talk about. Okay. Now, what is transition function and what is extended transition function? Look at, guys, we are going to understand two words here. Let me talk about DFA. I just give a DFA to explain this. And look at this, is it DFA or not? Is this DFA or not? Come on, quick. Is this DFA or not? Yeah. Is it DFA or not? Yeah. Bug finding in programming, Nikhil Jain. Yes, it is DFA. Now I'm trying to help you what is delta and what is extended delta. Because if you ask me delta, delta A comma A, you have A only. Delta A comma B is B only. Delta B comma A is B only. Delta B comma B is B only. Here delta we use just for a symbol. Did you see that? Q cross sigma derives a Q. Yes or no? So everything you take, this is belongs to Q, this is belongs to sigma, and this is belongs to Q. Yes or no? That is the definition of a transition function. A transition, we are talking about a symbol. Yes, it's one move, one input symbol we are going to read at a time. But what is extended transition function? That is extended delta. It actually talks about you take any state. It doesn't matter A only. It's your choice. You ask me any string. It's going to show a path. If it is DFA, you will have a Q. If it is NFA, you will have 2 power Q. Sigma star, you will have 2 power Q in NFA. Because multiple paths are possible there. Okay, what does that means? Look at here. I can read a string from A. Of course, I am only taking from initial, no need to be. You can take from any state, it's okay. Just tell me, from A by reading epsilon, it's A. No transition, but there is a path. That's extended transition function talks about basically a path on a particular string. And transition function talks about a move or transition on a symbol. Yes. Everyone? Yeah. A comma A, you have A comma B, B, A comma double A. after reading double A, like A on, I'm not showing everything, but it is the path that goes to A finally. How did you get that? A on A goes to A on A goes to A. So here, which one you're talking about? This is the result. This is the halt. Very halt. And A. Finally we'll halt at B only. After reading everything, like from B, by reading A, B only. Sometimes you may go different states, that's okay. And where do you halt? You halt at B. So understood what is the difference between transition and extended transition? Transition is just what you have designed, but what you want from the machine is extended transitions. Yes. And in the exam, they have already focused on this extended transition in the previous years. So it is probably possible in the coming exams too. It is predicted. Everybody? Yeah. So this is called as extended transition function. Yeah. For DFA. This is for DFA. Yeah. Everybody clear what is the transition function and extended transition? Yeah. In case you didn't understand this, just work out a little bit, you will get it. Yeah. Clearly with the examples I'm showing how they are differed. And when it comes to the question, when I ask A comma epsilon, you don't have anything. But when I ask extended delta from A itself, you have a path, 0 moves. So path is 0 or more moves, sequence of moves, and transition is the 1 move. And from A there is no move on epsilon, 0 move, that's why we have a pi here. Look at the difference between delta and extended transition. Transition and extended transition, guys. Fine. Move. Dead state and non-final. Some people are not aware of the dead state and non-final. Both are not same, guys. Okay. So what is dead state and what is non-final? When I am talking about non-final state, it may be dead or may not be dead. Doesn't matter. Non-final means, what is the meaning? Right? Any string that halts at non-final is rejected basically. Correct? Non-final state is going to represent, to understand, non-acceptance. If any string which halts at non-final, we say it is not accepted. Even dead state also same. Then what is the difference between non-final and dead? This is may or may not be dead. May or may not be dead. It is not required. Then what is dead state? It is definitely non-final. It is non-final. It is non-final. But from this state, there is no path to reach to the final. There is no path that can reach to the final from the dead state. Yes. No need to be self-loop. That is what I am giving a definition. Okay. Those people who have not done so far, let's try. Then who is the dead state here? Let's try. Who is the dead state here? Come on, guys. 1, 2, 3, 4. Which is the dead state here? We know 1, 3, 4 are non-finals. Yes. And who are the dead states? Who is the dead state? I'm waiting for your answer. Those people who are not designed such a way. So please let's discuss this. Which state is a dead state? Yeah, Vaishnavi. That's why I have taken this example. Navjit, only 4. Here 3 and 4 are dead states. If you apply minimization, this will be combined. 3 and 4 are dead states because both are non-final. From them, there is no way to reach the non-final. Right. So far you designed only self loops. Guys, dead state, no need to just be self loop. Everybody, 3 and 4 are dead states. Once you go to 3, there is no way to go back to the final. Yes. Understand, in the minimization 3 and 4 combined, there it looks like a self loop. Not here, need not be here. Yes, clear? So understand what is the meaning of dead state. Once you go to 3 and 4, there is no way to accept a string. Then why did you go there? Because I understood I don't want to accept anymore. Then I go to them. Everybody? But 1 is the non-final. That is not a dead state. Still there is a possibility to go to the final. So that's why 1 we didn't make it dead. Yes. Clear? Everyone? Okay. Now we have 3 words. A DFA, complete DFA, minimized DFA. All are, something different. Let's see. Okay, I'm writing something, guys. Just look at. Look at this one. Is it DFA or not? Is it DFA or not? Yes, it is DFA. From every state you have a transition, one transition for A, one transition for B. You can see that from state 1, from state 2, from state 3. But it is not a complete. Who is the complete DFA here? Who is the complete DFA? If every state is reachable from initial state, like this motion, if I draw, but we always draw a complete only. Now look at this motion. Now this is the complete. Previous one was not complete. Why it was not complete? Because 3 is unreachable. 3 was unreachable. Now every state is reachable from initial state. Such DFA is called as a complete DFA. The DFA need not be complete. You can design a complete DFA or you can design not complete DFA, but DFA definition has to be satisfied. Yes. What is minimum DFA here? What is minimum DFA or minimized DFA? It's something different than previous definitions. It is DFA, but in the world for this language, it is unique. That means you have the 1 and 2 might be combined. You will get this motion. All the 3 are accepting same language, guys. Maybe this will be combined. You may make one state in future. Oh my God. How can we reach? You can't see the path. 1 to 2 on A, you have a path. It's not reachable. What is this then? Not reachable? Lavjit. Already there is line. Can't you see that? This is the initial. Come on. What are you looking at? Who was asking? Lavjit, what is that question? Can't you see this line? Is it unreachable line? This edge, is it reachable or not? Come on here. Reachable on any string is fine. Kya question पूछ रहा है यार? Okay, what is minimized DFA? Here, understand, I'm taking, guys, here M1, M2, M3. If you observe, language accepted by M1, language accepted by M2, all are same. There is no difference. All are trying to accept something A plus B whole star. I will talk about that. Every string is acceptable. Every string is accepted in these 3 machines. Only the way you design is different. Are you clear? What is the relation between them? Every minimized DFA is a complete and every complete is a DFA. So when you look at these 3 motions, I will just give a relation for them, guys. If you have all minimized DFAs, I can call them as complete DFAs, guys. all complete DFAs in the world, and all DFAs you take. This is how we can understand. Every minimized DFA complete, every complete is a DFA, but DFA no need to be complete, complete no need to be minimized. Everybody, even though everybody represent same, every machine you have other machine, but they have a different hierarchy. But if you ask what are the languages accepted by this, same. They do same job, only you design different. Right? The languages accepted by them, if you collect languages, what are the languages? All does the same job. All machines does the same job. That is set of regular languages. Okay, clear everyone? The difference between three machines. Okay. Now let's start designing one by one. Let's see how many of you are comfortable in designing machines. Tell me how to design set of all strings over sigma is equal to a comma b. I want DFA, NFA, everything that you are looking for. Yeah. We have written expression. I'm recalling it. Even we have written a grammar. Did you remember that? This is LLG, RLG or LLG you can write. These are the grammars. Now we are going for DFA and NFA. Yes. How to design? Initial state, epsilon is accepted and every string is accepted, right? So you can put a final state, you can put a self loop on A, self loop on B. But instead of drawing two edges, you can also draw other way, that is A comma B. It's not A B, remember, it's A or B. It's A or B, remember. And is this only way I can design? No, I can design many ways too. This is also okay. Even I have many machines. Only I want to represent that every string is accepted. Every string is accepted. I can go for the three machines also. What I am trying to do. Now, why we took the first approach? Because it is the minimum DFA. And obviously this is exactly same. This is exactly same. It's not different. Yeah. But remaining are not minimum DFAs. What did you understand from this point? Note. Keep a note somewhere. Every regular language, how many DFAs I can design? Every regular language. If the language is regular, how many DFAs? Infinite equivalent DFAs. Infinite equivalent DFAs possible. Right? Only the difference is how many minimum DFAs. If I ask, no, 2. For every regular, how many minimum DFAs? Every regular, only one, that is unique. Only one unique minimum DFA exists. Note 1 and note 2. Yes. Everybody, remember these 2 points. We can design infinite DFAs, but among them, only one DFA is the minimum. Only one exists for every regular language. Yes. It's the first machine we are trying to explore what is DFA. Then why should I call this a DFA? Why should I call this a DFA? Now let's try some other way. Now you understood there are so many DFAs in the world. Let me show you NFA also. This is not a DFA because the transitions are missing from every state, but still it represents same language but NFA. And this is also representing same language but very difficult to understand why it is A plus B whole star. Look at A plus B whole star can be designed many ways in the world. DFA, NFA. But DFAs are easy to understand because A and B you will have a path to explain. But in NFAs you might have symbols or you may not have a symbol at all to understand the problem. All of them represent same language. But here the last one, NFA with epsilon moves. You have additionally epsilon moves. So it looks complicated to understand why it is doing A plus B whole star. And NFA, look at, there is a path which goes to non-final on A, and it's very difficult why it is going to non-final, right? So definitions of NFA are really difficult right now. So what NFA says, if it is a valid string, at least one path that halts at final. Yes. Now here, what is the difference between all the three? We said this is a DFA, and we said this is not a, okay, it's, you can say not a DFA. Look at these three motions. And what is the speciality of these three motions, guys? If I assume M1, M2, M3, the languages are same. The first point, the language accepted by M1, M2, M3 are same. Only difference is this is a DFA, so you can call NFA, no doubt. It is NFA but not a DFA because so many transitions are missing. And this is NFA but not a DFA, but with epsilon moves extra. No need to say I have epsilon moves, it is visible to you. Yeah, you don't need to say NFA with epsilon moves, without epsilon moves. Obviously it is true with epsilon, without epsilon. Simply talk about NFA. Everybody? And all of them are simply finite automata, no doubt. Right, which is important for us? The DFA. Because designing DFA is challenging, and which is, we have algorithms to design DFA once you know any one of them. Right, look at here. If I ask you W is equal to A, how many paths you have? Let's take something A, P, Q and 1, 2. And AA, how many paths? A on A is A on A is A. Exactly one path. Look at that. Exactly one path. No doubt about it. And when I ask about W is equal to AA, it depends on what type of string you are talking about. Valid string, at least one path, also at final. Invalid string, you can't show a path to the final. You can't show a path to the final. Either path exists or no path. Either path exists. If exists, it also at non-final. If it is invalid string. Now, AA, is it valid string? Look at so many paths. P on A, P, and then P on A, P, one path. Second path, P on A, P, on A, Q. Other path, you try it, but you will fail. You don't have P on A, Q, Q on A, no path. And totally you have two paths here. And at least one path is it halting at final. Who is final? P. P is the final. Yes or no? Yes, that is the reason this is a valid string. At least one path also at final. And if I ask AA here, how do you get it? How do you get it? From 1 on epsilon, go to 2 and read AA there itself. And on epsilon, come back to 1 because 1 is the final. Yes. Clear? And don't assume that is only path. Wrong. There is another path. 1 on epsilon, 2 and 2 on A 2, and I can go back to 1 and I can come back to 2, and then also I can read A, then I can go to 1. Two different paths, no doubt, but you can see the difference between the AA you can get by keeping any number of epsilons. No, not one path, Sandeep. Already I am showing two paths. I can show you infinite paths. Do you want to see infinite paths? 1 epsilon 2 epsilon 1 epsilon 2. Later I read AA. Infinite paths, I have infinite paths, guys. Look at, I got a different path now. Infinite paths are possible, guys. Infinite paths for the same string AA because of epsilon. Why non-determinism? This is a very important. What is the difference between non-determinism and determinism? Deterministic motions, finite automata, every string exactly one path. Every string has exactly one path. How do you do that? Because the definition says that every transition you will have one next state only. You take any combination of input and input symbol and state, you will go to next state, that is a one state only. So finally we will get one path for any string. But non-deterministic motions, you don't know. Valid string, it will act different way. Valid string, at least one path. No guarantee every path all set final. At least one path. That means one or more paths. One or more paths. Among them, at least one path all set final. An invalid string, we don't know. But we are guaranteed no path all set final. That's guaranteed. Now no clarity what is happening. Only guaranteed is every valid string, at least one path all set final. That's all. By looking at this, you confuse a lot. Just remember, every valid string, at least one path all set final. That's all you can speak. Invalid string, no guarantee path exists. Because you can't show a path, sometimes the string is invalid. Yeah, non-deterministic motions are very difficult to understand but easy to design. Why do you approach them? They are easy to design. They are most of the time easy to design, but difficult to understand. Remember, difficult to understand because they don't show you how the string is accepted. You need to look at, is there any path? Deterministic finite automata may be difficult to design because you need to worry about exactly one path in designing, but easy to understand. They will never confuse you. Yeah. Clear? Okay. Second problem. I'll keep differences lot. Second problem, guys. Good morning, Nishu. Every string starting with A. Here I'm not going to give a techniques because for me to explain the techniques, concept itself it takes 1 hour, guys. But we need to complete within 1 hour whole topic. Yeah. The language is, this is not the plus course, this is not the regular course, remember. There we learn different way. Okay, and if I want to write a grammar, yes, I can do that. Capital A and capital A I do write recursion. This is what I can write using RLG. Okay, even I can write LLG, but you can try that. minimum string is what? A, right? So what we do, this is a minimum string, guys. This is the minimum string. This is the minimum string where A only accepted. Now after A, anything is accepted. A or B, doesn't matter. A followed by any number of A's and B's in sequence. From initial state, if you get a B, will you accept? No, right? You will reject. So you will go to dead state. Yeah. How many states? This is a minimum DFA. Less than this, there is no DFA, guys. With 2 states, impossible DFA, but NFA possible. This is a minimum DFA. Who is NFA? Who is the minimum NFA? It is already NFA. It is NFA. It is DFA. Remember, it is DFA. It is NFA, but it is a minimum DFA also. But it is not a minimum NFA. If I want to design a minimum NFA, clear? Oh, you can also design other way. That's what the confusion is. Now why we say non-deterministic? Because this is what I know what I am doing. Both represent same. Only the confusion is for A you have multiple paths. Yes, this is the minimum NFA, but there is also minimum NFA, guys. 2 states only here. What did you understand? If the machine is minimum NFA, then you could have more possibilities to design NFAs to accept the same language. Clear? What did you understand from this concept? What did you understand from this concept? If you, in the second machine, guys, in this minimum NFA, if you give me double A, I have multiple paths, at least one path also at final, because it's already starting with A. Yes. But if you ask me string starting with B, you will not have a path. You can see that in these 2 machines, you don't have a path for a B, because I don't want to take care, because it's not a valid string. Clear? Okay. Now what did you get? Note. Tell me, guys. Every regular language, how many NFS, DFS ho gaya? Every regular language, you can design infinite equivalent NFAs. But if it is, you want minimum NFAs, for every regular, don't say infinite, 1 or more, that's all you can say. Finite only always, infinite impossible in minimum, 1 or more minimum NFAs. Maybe 1 or 2 or 3, depends on the problem. Come on, 1 or more. More is also here finite. This is the finite. You can't go for infinite NFAs. With 2 states, guys, how many machines you can design? Only few, right? You can't design more. And for this problem especially, can you design some other machine here? There's a 2 minimum NFAs possible. 3rd minimum NFA, can you show that? Of course, with epsilon mouse you can show that. With epsilon mouse, if you have anything, you may show it. I don't know exactly, you can show that maybe. But these 2 are minimum NFAs. 3rd minimum NFA, it's a very difficult to find now. Yeah. Previous one, only 1 minimum NFA. This is the minimum DFA and this is also minimum NFA, guys. There is no other minimum NFA for us. Here minimum DFA, minimum NFA looks same. Okay, it depends on the problem. Right now you can't say anything about. Aditi, already free GATE test series is launched by Unacademy. You are late to realize that, Aditi. Vishnu sir showing the slide in every class. This is our free test series. Yeah. Come on. Set of all strings over sigma is equal a comma b where every string ends in a. Now we want ends in a. What is the expression, guys? A plus B whole star A ends with A. You want to design, you want to write regular grammar? Let me write. Yeah, in single line I am writing, guys. Okay, great. How to design now? See, A, again A is the minimum string. Do you want ends with A? So this represents ends with A. These are not ends in A. So whenever B comes, I stay here, I go back on B. Did you see that? Whenever B comes, we are halting at capital A. Whenever A comes, we are going to reach capital B. Clear? Ends with A. If I want ends with B, then I just swap A and B symbols. Just two states required in minimum DFA. But in NFA, this is already minimum, guys. It is also minimum NFA. Only for this problem. Only for this problem. But there is another NFA also. You can see that ends with A. This is also ends with A. This is the minimum NFA. There are so many. There are so many like this. But why I am designing? I know it because I know what is NFA definition. You give me any string which is ends with A, I will show you at least one path that halts at final. You give me any invalid string, I will never have a path to the final. Look at, follow the definition to understand the immersion. Any string that you halt at final, that is only ends with A. And every string which ends with A, definitely, at least one path exists that halts at final. These definitions you need to do rehearsal to understand these two motions, guys. Yeah. All are minimum NFAs here. All are minimum NFAs. Can you see that? But only one minimum DFA, guys. Yeah. Three minimum NFAs are there, but nobody asks how many minimum NFAs. It is important. Yes, few minimum NFAs, but either one or more. Okay. Set of all strings excluding empty string. Excluding empty string. Yeah. Except epsilon. Except epsilon. What do you do? A plus B whole plus. And what is your grammar? What is your grammar, guys? SA or SB or A or B. Yeah, I'm also showing grammar at a time because you will have practice for all of them. Yeah. Now, how do you design? Minimum A or B. Yes, minimum A or B. So, either A or B. This is the minimum string first. Now we need to focus on entire language. Okay, that is anything accepted after that, either A or B. This is your DFA. But you know many NFAs are possible, but minimum two states compulsory. So here this is the minimum DFA, it is also minimum NFA because you don't have NFA with one state. You have to believe this is also minimum NFA. Yeah. Two states. Next. Set of all strings where every string starts and ends with A. Starts and ends with A. What is the language? A or A followed by A plus B whole star A. minimum string is just A, guys. Minimum string is just A. So for that, first you design. Don't take double A. Double A goes wrong way. Right. Now try to expand this motion to understand whole language. And after A, any number of A is accepted. So ends with A, guaranteed. But only problem is you can't start with a B. If you start with B, you have to go to the dead state. This is the dead state. And from the second state, if you get B, then go to somewhere, but don't come back to initial because you can go to dead. There is a chance. And on A, come back to this 2. On B, stay there. That is the difference between 1 and 1 dash. 1 on B, it goes to dead, but 1 dash, 1 prime on B, it is self loop. That's why we should not go back to a 1 because of that 1 goes to dead state on reading B. Yeah. So look at 1 and 1 dash. Why you should not go to the 1? And if you can realize that, you can easily design the machines, guys. And look at, is it DFA? Did I design DFA from every state for every input symbol exactly one transition? Look at that. Yes, you require 4 states in minimum DFA. But NFA, you can delete dead state. You can delete that dead state. Yes or no? Yes, you can delete that dead state. So you'll get 3 states. Yeah. Oh, you can write a grammar. How do you write a grammar? Okay, starts and ends with A, right? A, okay, A capital A, you can't do that. So I'm just writing A capital A, or simply A I am putting here. And what capital A should do that? Remaining part, that's ends with A. Ends with A. You know how to do that ends with A? Using right linear grammar. That is A or B A or A. Fine. Okay, please try the another one. Ends with same symbol. Yeah, Nishu already written that grammar, that expression. Now try for machine. Prem, that depends on what languages you do. Minimum DFA, there is no answer. I can't tell you what is minimum DFA. You can design it. Yeah. Anybody, how many states you got for starting and ending with same symbol? Yeah. Don't mix up. That's not a regular grammar, Pratiksha. रेगुलर ग्रामर बीच में होगा क्या नॉन टर्मिनल? लैंग्वेज तो सही तो है, ग्रामर तो सही तो है, बट लेकिन वो रेगुलर ग्रामर नहीं है. कॉन्टेक्स्ट ग्रामर डिजाइन कर रहा है प्रतीक्षा. ठीक है. 4 5 कम ऑन देख लेते हैं. अगर ए आया ना, यू हैव टू डिजाइन 2 डिफरेंट वेज, राइट? ए आया, यू हैव टू गो दिस साइड. B आया, you have to go this side. अब क्या प्रॉब्लम है? This is going to worry about ends with A, this is going to worry about ends with B. यहाँ B आया ना, तो go to somewhere, come back on A. Stay for B on some other state. A go somewhere and stay on A and come back on B. Here 5 states. 5 states. Okay, Prem. Yes, 5 states. 5 states. Even you want to design NFA, it takes 5 states. Yeah. Okay, now starting and ending with different symbol. This is going to be easy. This was the previous model gate question also. If I start with A, you must end with B. This is a minimum string. If I start with B, you must end with A. But don't combine the final states. Both have different jobs. And now you have 2 problems. You have 2 problems. If I start with A, end with B. End with B concept, concentration. And ending with B. If not B, then come back on A. Here also same. Ends with A, focus. If B comes, come back. Because our target is different symbol ending. Clear? Here 5 states. Here also 5 states. Yeah, in both DFA and NFA, it's a 5 states. Yeah. If you're watching this video, guys, please like this session. Please like this session. Thank you so much. Forgot to like, please do that. Okay. 8th one. You know, expression I forgot, right? What is the expression? A plus B whole star B. Or if I start with B, you must end with A. This is easy expression. Yes. And exactly 2 length, that is A plus B whole square. Right, that is AA or AB plus BA, BB. Now, this exactly 2 length, it's very easy to track. Now, first we will go for 0 length. We don't want to accept. On 1 length, A or B correspond to 1 length. We don't want to accept. And another A or B followed by 1 A or B which gives you 2 length exactly. But after that you don't want to accept. Then on A comma B you go to dead state. This dead state greater than 2 you will reach here and stay here itself. It's total 4 states in minimum DFA. But if you want NFA, just 3 states. The dead state is not required. Yeah. Fine. क्या सही था? 2 इनिशियल होता क्या? At least 2 length. Set of all strings which are having at least 2 length. पढ़ना पड़ेगा guys. At least 2 length. Set of all strings which are having at least 2 length. How do you design DFA for this? At least 2 length. Again same concept, right? If I want to write an expression which is A plus B whole square dot A plus B whole star. Yeah, we have seen so many expressions that I have explained you already. When we have more than one condition, you can't multiply. Some of the states you might have different concepts. Okay, Cartesian product will guarantee DFA, will not guarantee minimum DFA, Prem. You need to understand. Okay. Two length need to be minimum, and then 3 length, 4 length, 5 length, all of them can be. So this is NFA and also DFA. In both of them, same answer. Everyone? Yeah. Okay, at most 2 means 0 should be accepted now. 0 length and 1 length and 2 length. That's all. But 3 length onwards we don't want to accept, so we go to dead state. Did you remember the expression for this that we have seen yesterday? Like a plus b plus epsilon whole square. Remember this? Yeah. Now here 4 states. 4 states in minimum DFA. But how many states in NFA? 3. Dead state is not required. Yeah. And before going to the other problems, let me help you. The new batch is going to begin soon, and which is tentatively planning. Of course, it might be delayed a little bit, but June 25th we are planning. The batch is going to begin from the January 25th, and it might be delayed. I don't know exact information, but tentatively is going to be planned from Jan 25th, and which is first batch for 2022. In case if you are very seriously preparing, you know that the basics we cannot explain in less time. That's why the way we construct, I am not explaining, I am just showing how to construct, but not in detail why I am taking 3 states or 4 states. I'm just designing it. Yeah, there are so many things we need to learn. If you are learning for 2020 to 2023, believe me, you have to, means not required, but if you are taking the plus or iconic, you can learn all the concepts systematically, one after other, and with proper time. The concept that you take, that I am explaining right now within 1 minute or 2 minutes may take 1 hour that you do not know. So there you will be learning exactly this concept need to be taken for 1 hour or half an hour. We know best. So whoever joins the plus or iconic, those people who are going to learn all the concepts systematically with the proper dedicated times. Okay. Next one. How many states required now? Oh, great, expression came out. Logic. Yesterday we have written exactly 2A's. This is exactly 2A's. Yeah, 3 states. Now minimum string is what? Minimum string is AA. Focus on this string. It will help you to design completely. First accept minimum string to start a machine. Yes. Now I need to focus on my language. Okay, third A should not come ever. So I will go to dead state. And B's doesn't matter how many comes from any state, put a self loop. Yeah, 4 states in minimum DFA. 4 states. If you want NFA, 3 states. Yeah. Understood the concept? It's just like exactly 2 length, guys. Exactly 2 length, also same concept. 4 states in DFA and 3 states in NFA. Okay. Next. At least 2 A's. At least 2 A's. Did you remember that expression? 2 A's and remaining it's anything. A plus B whole star. Because 2 A's guaranteed. Of course, there are infinite expressions to write. Only I am showing one. Okay. What is the minimum again? Minimum 2 A's. Minimum 2 A's. So we will accept first minimum 2 A's. We will accept first minimum 2 A's. Then now we need to worry about now achieved minimum 2 A's. Now any number of A's is fine after that. Yes. Now B doesn't matter. So B is what we do. Put a self loop. B. Already you can have a self. You have self loop. You can write a comma B. This time you need 3 states in DFA. You don't need a dead state. And how do you know that 3 states? Because of the practice you can get, and we have techniques too. Only, because of the lack of time, I am not explaining much in detail, but those people who are already studied a little bit, they can easily crack it. Right? Those never studied TOC yet, and you will struggle a lot to understand these concepts. Yeah. Next. Number of A's at most 2. At most 2 A's, right? 0 A's you can accept, 1 A you can accept, and 2 A's you can accept. And now B's doesn't matter, but third A never comes. Third A comes, go to dead state. B's you put a self loop from every state because we never count a B. Any number of B's can happen. Yeah. Okay, now 4 states in minimum DFA and 3 states in minimum NFA. And I have, technique, guys. Those people who are not able to construct these machines, please go to the playlist and find the long-term batch theory of computation already taken. Even crash course also. This is the 3rd time I am taking theory of computation. But long term, I have taken nearly 70 hours, and there every machine I have designed with an approach. You can follow that. Yes. Okay, 14. Even length. Even length आपको याद है शायद. याद है क्या? This is the regular expression. Okay, how many states required? How many states? Even, 0 remainder and remainder 1. The lengths when you consider, yes, when you divide with 2, the remainder, see, remainder 1 and remainder 2. 2 will become 0. Remainder 2 never happens, right? Either remainder 0 or 1. So this is 0 length and 1 length, 2 length, 3 length, 4 length, 5 length, 6 length, 7 length, 8 length and 9 length. So they are going to keep on repeating if you are adding any length to them. Yes or no? Yeah. So first state is represents even length. Second state represent odd length. Exactly, two states. In NFA and DFA, you will have just two states. Yeah. Odd length, odd length. Remember, A plus B added to even length. That's concatenated. Here, now we'll make odd state is the final state. This is odd state. And A or B, A or B. Now look at 0 length we didn't accept, 1 length we have accepted, 2 length no, and 3 length accepted. You can stop any time, but if it is odd length, definitely you should alter at final state only. Yes Nishu, TOC के बाद compiler start होगा. Okay, length of string is divisible by 3. Did you remember the expression? A plus B power 3 whole star. This is a multiple of 3, yes or no? It's divisible by 3, also called as multiple of 3. How many remainders required now? 3 remainders, guys. 3 remainders. 3 remainders. 0, remainder 0, remainder 1, remainder 2. And we want remainder 0 is the final. And 1 length, and second length, third length, make a cycle. So now, if you look at the lengths, 0, 1, 2, when it is 3, will come back, 4, 5, and 6 come back, 7, 8. Did you see that? These are nothing but 0 mod 3. This is nothing but 1 mod 3. These are nothing but 2 mod 3. In the exam, they may ask about remainders. Gunjan, I don't know whether I teach or not. I promise to teach every important concept. For me, that is not at all important, Gunjan. In the last class, we can cover up that missing topics in the last day. Yeah. Okay. Number of A's is even. Number of A's is even. Did you remember that? How difficult to express? But B is also there. So we should write B stars everywhere. Fine. Now, no A accepted, that is 0A, and 1A is odd A, and even A come back. But now this is A's is even, but B's can be any from any state. So we will have a B self loop all the time. Yes, 2 states. Clear? Even length is also taking the same 2 states, but length is even means A comma B we change. So this represent length you are worried, and this represent symbol you are worried. Symbol A you are moving means symbol you have taken important, and length you have an importance, then you move on A comma B. So carefully take the transitions. Are you worried about A comma B or A? Odd. Odd length. Odd length or odd A's? Odd A's. So 1A accept it, and 2A come back, and 3A again accept. So but B's doesn't matter, so B's you keep a self loop. So this represent even A's, this state represent odd A's. Yeah. number of A is divisible by 3, same concept. One A and second A, third A, you can go to another state, but instead of going another final, you can come back to the same final. Divisible by 3. If I don't have the bit, this is the answer. But I have base, I can have any number of base from any state, so put a self loop. So 3 states in both DFA and NFA. Okay. Second symbol from the beginning is A. Did you remember that expression? First symbol is any, but second is A and followed by anything. Yeah. So how do you do that? How do you do that? First is any. Any means A comma B. Second must be A. And then after that everything is okay. But second is not A, then you should go to dead state. If I ask nth symbol is A, then how many states required? N plus 2 in DFA, n plus 2 states, and n plus 1 that is not required in NFA. Minimum, yes. Yeah, n plus 2 states. Where is 2 states? Which question? I don't know. Okay, fine. 21. Second symbol from ending is A. One of the difficult one. Maybe you don't understand in short period of time. Please watch the other video in TOC playlist. This is a crash, right? We have a long-term batch. They have taken TOC already. They have explained almost 20 minutes this problem. Okay, there you can focus a lot. Ending in A, that's last is anything. A and A plus B whole star. And what is another way to write? Ends with double A or AB. So I'm focusing on ends with double A or AB. So A, this ends with double A. And AB, this ends with AB. Now I'm going to expand this motion to understand this language. Yes. Now any number of bits. Now look at minimum double A, AB accepted. Now I'm focusing on my language. Any number of bits, I will wait because I should never go to dead state, because ending condition we never go to dead. And second state already covered, A and B. Third state AB missing. Fourth state AB missing. From third A comes, you can stay there because A, always second symbol from ending is A, and A followed by B will become AB. You can go to this fourth state, and from 4 A comes, then after AB A comes, then look at second symbol is not going to happen, right? Now you come back to 2, after that B comes or A comes, you can go to final. If B comes, you can go to initial state. And it's really gonna difficult for the beginners I am talking about, and such kind of questions can't be understood within 1 minute or 2 minutes. You need to focus a lot of time to get this idea. Yeah. But I have already helped, I have already designed this motion in some other way too. So we have 4 states. We have a shortcut also. If anybody asking nth symbol from end is A, then how many states required? 2 power n, 2 power n states. In minimum DFA. NFA is very easy. NFA you want to design? Before second symbol anything, from the second last is A and last is anything. Just it is very easy to design. This is a minimum NFA. Minimum NFA just takes 3 states. In general, nth symbol will take n plus 1. N plus 1. You want to talk about minimum NFA? N plus 1. N plus 1 states in minimum NFA. Yes. Don't ask me, sir, how do you design it? Really, I'm telling you, such motions cannot be explained within 1 or 2 minutes. Today, I'm doing a very worst job that I don't like to teach this way. But only I promise to complete TOC in few days. So that is the reason I'm teaching. TOC never be learned in this way, guys. But if you are understanding, then this will help you for revision and this will help you for quick completion. That is the only the way I'm trying to help you, but this is not the way you should learn. Remember my point? Those people who want to complete in less time and you need to work hard, and if you have already learned it, then this is gonna be very helpful. Okay, 22. Containing AB. You know AB, right? Containing AB means somewhere AB definitely there. Yeah. Minimum how many states required? Minimum is AB. AB means 3 states compulsory. A followed by B. And now after AB there is no job left because AB already seen. But before seeing AB, all the combinations you need to wait that only B's can come. Or after any A's comes, still AB not happen yet. Now this is a DFA. This is the DFA. Right. But you can also, this is the minimum DFA. Obviously it is a minimum NFA. I can design minimum NFA this way or some other way too. What is other way? I can just design very simple way AB and AB. I'm just looking for AB somewhere happens in my string. This is just minimum NFA. Here also every string which contains AB, I can show a path that goes to final. Yes, at any of this, just take 3 states. Yeah. Okay, 23. Starts with double A or double B. Yes, expression is double A plus double B followed by A plus B whole star. Correct. Even we have written expression yesterday. That means either double A or double B you should go to final. It is just starting, so I can combine the final state. Not a problem. I can keep the same final. After that job is everything accepted because you already started properly. But if you don't start properly, you need to go to dead. Example, after A, B should never come. After B, A should never come. If they come, they are invalid strings. Right? 5 states exactly. 5 states. Five states in minimum NFA. Correct, correct. Okay. Double ends with double A or double B. Oh yeah. It's again difficult problem, but anyhow, I have to do this way. Double A and other one is double B. 2 problems we are solving parallelly. 2 problems, guys. Yes, 5 states. This was the previous year gate question 2. This was the previous year gate question 2. Yes. Everyone? Yeah. If you want NFA, that's a different. I can keep A comma B here. Okay, this side AA and ends with double B. This side BB. And just it takes 4 states in minimum NFA. Okay, now missing transitions really gonna be difficult because one side you need to focus on ending with double A, other side you need to focus on ending with double B. Yeah. So this side A stayed final, but B comes. Just go back. Where do you go back? Very, very difficult, guys. You go back to ends with right. Go back here. No, because after that B comes, you should go to final. So you should go back here. B followed by B is ending with double B. So that's how you should try. But we have techniques to design that. I'm just blindly designing now. B self loop. A, just go here because A followed by A is ending with double A. Yeah, don't worry much about it. 5 states you got it. Just click it. Yeah. 5 states in minimum DFA and 4 states in minimum NFA. And minimum NFA is always easy, so you can approach. Okay, W contains double A or double B. Containing double A or double B, guys. It's same problem. Just now we did, right? Like, but this is not a starting, this is a containing. After that, anything is fine. It is NFA. If I ask NFA, just 4 states, you say that. But DFA, you need to cover up remaining. After A, B comes, come here. After B, A comes, go there. That's all. That's all. Did I miss anything? After B, A comes, okay. After A, B comes, this side is missing. And after B, A comes, go there. Yes, yes, I was missing it. Fine. Clear, everyone? You can cover up the same thing. From 2, B was missing. From 3, A was missing. You can do that. Yes. Same transitions. Yeah, Pratiksha made it complete. Yeah. So 4 states. Even minimum DFA also. NFA, DFA both. Yeah. Okay. So in this session, what we have learned, guys, DFA, how to construct, and NFA. I've just shown like a revision, but really constructing these machines, you need to have a good practice. And you know, if NFA has n states, then how many states once you convert to DFA? There is an algorithm we can convert to DFA. How many states here? Minimum DFA we are talking about. Minimum DFA, how many states? Less than or equal to 2 power n. At most 2 power n. There is an algorithm. It shows always 2 power n state DFA exists. It means minimum DFA is either 2 power n or less than that. Yeah, this is the very important concept, but algorithm we don't need for exam. So I am helping you guys. Those concepts which will be which are discussed in this session and which will be discussed in the coming session are important for GATE, and those things which I am not discussing, it means they can be ignored or you can understand if you want them, right? Like NFA to DFA, this concept is important, but algorithm not at all important for the exam point of view. And this question was asked 3 times in the GATE so far. If NFA has n states, minimum DFA has at most 2 power n states. Minimum DFA. Yeah. Maximum, yes. Maximum. At most means maximum. Okay. Tomorrow I've already disclosed. Yeah. कितने बार बोल रहा हूँ मैं? How many times I am talking about my schedule, guys? I don't know how to explain to the people. I'm showing every day schedule, like, today I take this, and you are asking again, what is tomorrow? Tomorrow, should I say that? Okay, please watch my video from the beginning. All the questions are there in all slides, guys. Some slide I'm showing. Okay, everything, even timing and schedule, everything is clearly discussed on every day. Please follow class regularly, guys. And after this, after this class, you have till 13th January, right? Yes, mathematics class that begins at 11:30, and then you have 2:30 p.m. computer organization. Vaishnavi, GATE PYQs already series started. Guys, anybody has a doubt, anybody more than this, go to playlist. Everybody knows how to go to the playlist of this channel? How everybody knows? Everybody knows? Please go there, and whatever you ask, it is already there. Playlist of this channel, visit there, playlist, and you will find every answer. GATE PYQs already started, and please watch them whenever you have the time. And please follow this URL, https://unacademy.com/DEVALIVE is my profile on Unacademy. You can enjoy my free classes there. And this is our Telegram channel, Unacademy GATE CS. And the files are uploaded there, and also links every day will be shared of every subject. We have so many free YouTube channels. Please share with your friends. I don't know, Nikhil. I have to think about it. Today I have not planned any session, so that's what I'm not talking about. I had in mind, I will look at it. So please like the session and share it and subscribe. Thank you so much for joining this session. Tomorrow we are going to learn closure properties and identifying regular languages.